My name's Brendan, so I'm from the University of Wollongong and part of the Desert Rose project. So we're basically a student team that designed, built and operated a fully functioning smart solar powered house for a competition that was held in Dubai in November of last year. So I'm not sure if many of you were here around September last year. I did a presentation just as we'd essentially finished building the house here in Australia, and then we shipped it on to Dubai. So today I'll just give a bit of a background on the Solar Decathlon for those of you who weren't here last time, as well as a little bit of a background on where we got up to the last time I did the presentation here with the Smart Energy Council. Then I'll dive into our journey actually in Dubai. So we had a number of students and staff go to Dubai to build and operate this house for the competition. Then we'll go through kind of the day in the life of the competition and the results that we obtained, and then where we're heading to next with the house and the project. So a quick bit about myself. I was a graduate with a degree in electrical engineering from UOW in 2016. During my undergraduate, I was an engineering cadet for a company, ActuAGL, so I primarily worked with more large-scale electrical things like substations and transformers and that sort of thing. So I did have zero experience building a house at all. I received a PhD scholarship to begin working on the Desert Rose project to build this house. That was at the beginning of 2017. So I took on the role of building services manager, and now I'm back at university just completing my PhD over the next 12 months. All right, so the Solar Decathlon itself. So the Solar Decathlon was started in the year 2000 by the US Department of Energy. So basically, Richard King, who founded the Solar Decathlon, wanted to promote residential solar PV and those sorts of technologies because they weren't really common at that point in time. And since then, it's really grown. It's basically held nearly all over the world at the moment. So other than Antarctica and Australia, it's basically been on every single continent, as you can see here: Africa, Europe, the Middle East, China. So hopefully we can get one here in the coming years. But essentially, the Solar Decathlon challenges teams from all around the world to design and then build and then operate fully functioning net zero energy homes. So being a decathlon, it's made up of 10 different competitions. Now these usually vary slightly from competition to competition, but these were the contests that we were dealing with here, or that we were dealing with in Dubai, sorry. So they're basically a mixture of judged contests where you get a jury of industry experts walking through your house and they basically judge it on the pitch you give them through that tour, and then measured contests. So the measured ones, things like comfort conditions, so how well you can maintain temperature and humidity in your house, your energy management, so how much energy you use from the grid, how much energy you export, even things like variable tariffs they incorporate. Sustainable transport, so we had to drive around in an electric car during the competition and try and minimise the amount of energy we used. And then another interesting one is house functioning. So it's all well and good having these really smart, sustainable solar powered houses, but it needs to operate like a house. So we need to be able to wash clothes, boil water, use our oven, all those day-to-day things you do in the house, they test during the competition. And then the remaining competitions are basically judged competitions, as I was mentioning before, where you get the jury come through and look at your house. So things like architecture, communication, so how well you, put across your team's message, sustainability, energy efficiency, those sorts of things. So we competed in 2018 in Dubai, but that wasn't the first time the University of Wollongong has competed. So in 2013, they entered the Illawarra Flame House. So it's important to note too that we're still the only Australian team to ever compete in a solar decathlon. I'm not sure why. I think maybe due to the cost. You can imagine it's quite expensive building a house and shipping it halfway around the world. But UOW's first entrant was called the Illawarra Flame House. It was based on a building retrofit. So essentially they went out to the Illawarra and found a house that was built in the 1950s, was a fibre asbestos home. Obviously those houses are really energy inefficient. So what they did was they got the floor plan for that house and basically rebuilt it and showed how you can apply retrofitting technologies to essentially improve the energy efficiency of that house. So they did really well with that. They actually won that whole competition in China in 2013, and they received 956 out of a total of 1,000 points. So that was a world record as well that stood for 5 years. So we had big shoes to fill coming in with the project in 2018. So our second entrant, the house was called the Desert Rose this time around. So the competition we were competing in the Solar Decathlon was going to be held, or was held, in Dubai, in the UAE, in November of last year. Over 40 teams applied to compete in the competition. Only 22 were accepted, but then only 15 made it to the competition. So, as you can imagine, building a house in a pretty short period of time and shipping it around the world is a pretty big task to undertake. So some teams unfortunately weren't able to get all the way to the end and take their house to the competition. So the aim for us was to basically design a house that celebrates human life rather than just having a smart solar powered house. So we wanted to aim this house to be able to assist people living with age-related disabilities like, dementia if they had a wheelchair or a walker, those sorts of things. So, last time I was here. At that point, it was September of last year. Team UOW had just completed building the house twice here in Australia, but we never actually got to a full completion. So we more or less had the house in its final form, but there were a lot of touches that we just left off just due to time constraints. So we just sent the house over to Dubai in 7 40-foot shipping containers and 1 20-foot shipping container. We're around 8 weeks from heading to Dubai ourselves, and we were feeling positive, but we didn't really know what to expect from the competition. You never really know how tough the other competitors are going to be, and we're never really sure exactly how our house was going to perform in the hot, humid Dubai climate. So this is about where we were at last time I spoke here at Smart Energy. And that was us the last day we built the house. So that brings us to late October of last year. Around 35 students and 5 staff made their way from Sydney all the way to Dubai. A small team left a few days earlier just to pick up some small supplies and that sort of thing ready for the competition. Each team had 15 days to construct their house, so that was from nothing on the ground to a fully functioning house. Site was open for construction between 7 a.m. and 11 p.m. And then after the 15-day construction period, we had the 10-day, I guess you could call it competition period, where the house was measured, judged, and toured. So, as I mentioned, a few of us went over to Dubai before the competition started to grab a few last-minute supplies and that sort of thing. I was lucky enough to, with a friend of mine, go watch Australia play Pakistan in the cricket. I was surrounded by thousands of Pakistani blokes and we got smashed that day. So that was a really interesting experience to get my journey in Dubai going. A couple of days later, basically the rest of the team arrived, so all around 35 students along with 5 staff. And this was our first day visiting our site. So essentially the site itself wasn't actually in Dubai. It was around 60 kilometres outside of Dubai, next to a solar park that they have out there. So that was a bit interesting for us because there was no accommodation out there. So that meant a 1 hour trip out to site every day and then a 1 hour journey back. So you can imagine after some long shifts, there'd be plenty of sleeping on the bus on those long days. So that brings us to day 1. Everyone's really excited to get into construction. So we were working in 2 shifts, one from 7 p.m. to 3 p.m. and then one from 3 p.m. to 11 p.m. But a lot of the times, depending on the student and what they're involved in, a lot of people ended up having to work double shifts all the way through, just depending on what was going on that day. So I guess that was one thing we just had to put up with, those long working hours, but everyone was really committed to the project that they were happy to do it. So on day 1, we laid down what's known as our pods. So you can see one of the pods here. So basically the pods were kind of pre-constructed elements of our building that had both floors and walls connected. So we did our bathrooms in pods just because we wanted to avoid tiling while we're in Dubai, just due to the time for tiles to set and that sort of thing, as well as our plant room. So all of our electrical equipment was contained in a pod. So these were laid down first and were essentially squared up, and then basically the building was built around that. So the pods went down first, and then following that, all of our floors went down around it. So pods and floors were done in 1 day. Next came our walls. So the walls were essentially slid into the container and packed really tight. Due to the container height, we actually had to tip a lot of the walls on their sides. So we had quite high ceilings in the house, around 2,600 mil, because that's pretty common in the UAE. So one of the challenges was actually getting the walls out of the container and then flipping them and then bringing them into place. So day 3 comes around, most of the walls are up by that point, and we can begin working on our roof. So the roof modules come in and basically sit on top of the house. So this is our first and largest roof module to go on the house. It's what's actually called our, or what we called our HVAC cage. So all of our heating, ventilation and air conditioning equipment was actually contained in this one unit, or majority of it anyway, and was placed on the house first. So here's a quick, overview of the system itself. So as you can see here, majority of the equipment in the house was installed here above our bathroom. So that had a few advantages. One, basically maintain everything in one spot, so if anything went wrong, we can get access to everything quickly. And two, and that was our outdoor heat pump and PCM tanks that I'll get into a bit later. But the biggest advantage for us was basically everything could be installed on the ground. So you see here on the slide, we could install all of the mechanical equipment on the ground, off-site, and then once it was installed, we could just bring it onto site and lift it onto the house. So from a safety standpoint and from a time standpoint, it was a really beneficial thing for us to do. So on day 4, we began working on the electrical connections and the connections of our HVAC ducts as well. So one challenge that we had to overcome was how do you actually connect these ducts in adjacent roof modules when we're bringing the house together. So one solution was to actually implement a removable ceiling in the bathroom. So you can see here on the left-hand side, that's basically when the ceiling was off, and the right-hand side was the finished product. So essentially we used this product called Modwood, which is essentially recycled wood, and we use that in the ceiling and then just painted over it. So you can't really tell once it's there, but basically it was it was really beneficial for us because whenever something went wrong, we could just quickly pop off a section of ceiling, jump up there and fix anything that was happening. The other one for us was we actually left a section of gyprock off the length of the house that you can see here, and it was really beneficial for us because we could connect all the ducts that ran along the house as well as our fire sprinkler pipes and those sorts of things. So this section just here and here was left off the house. Everything was connected, tested, and once that was done, we just set it with gyprock and you wouldn't even know it was there. So day 4, we're continuing on with the roof modules and the electrical connections. So the electrical connections were a bit easier than the mechanical connections. So what we just do is basically bring one roof module in and then set it down just 300 mil off the adjacent roof module, as you can see here. All of our electrical cables had quick connects on them, so we'd just plug everything in, then the roof module would slide in and get bolted together. Similar with our electrical connections that went down into the walls, like your switches and power points and those sorts of things. They essentially had quick connects, you can see here, that just drop down from the wall into the ceiling. So we'd just get our hands up in the ceiling behind the cornice, then you'd connect the cable when the roof module was in, and then basically just shove it up into the roof. And then once the connection was made, a cornice would be put in, which would hide the cable. So that was a really good method for us, nice and quick and safe. So day 5, we pretty much had more or less a house up by that point. So a majority of the electrical connections were made. We still had a lot of work to do on the exterior, but we more or less had a house. So at that point, we started working under the house with things like plumbing and our other remaining electrical connections we had under the house. There was less than 500 mil of clearance under the house, and we were basically working on a compacted road base of gravel. So it was really, really uncomfortable under there. So I'm not sure if you can actually see it here, but one of our team members actually got some insulating foam and just taped it to his elbow so he could work over the house comfortably. But yeah, people were still happy to go under there and get the work done. Day 6, we began running power under the house, so we had to run power obviously from our house to the main panel of the Solar Decathlon organisers. This is a typical bus ride to and from site. That day as well, we also began digging a trench. So as I was mentioning before, the ground was that compacted road base, so you can imagine getting through that with some shovels and picks was pretty difficult. So we made sure we did that during the evening to avoid those 35 to 40 degree days. Here's another one on the bus ride. As I was mentioning, a lot of people working really long hours, really hard. So everyone got really good at sleeping on the bus. But we're also treated to some pretty nice scenery. So every morning we catch the sunrise across the desert on the way out to site, which was really nice. So on day 6, we also started installing what's called our second skin wall. So essentially this is a concrete facade that wraps around in the northern hemisphere. It's the south, west and east sides of the house, so the sides that are being directly hit by the sun. So this wall is made out of a foamed concrete, so it's much lighter than regular concrete, and it also contains 20% recycled glass. So we use this as essentially a passive shading element. And the interesting thing is, in Dubai, this wall was actually, was working really effectively. So the wall would sometimes reach up to 45, 50 degrees, and the actual inside wall that our cladding of our actual house was usually 15 degrees cooler than that. So it worked really well in the Dubai heat. Day 7 rolls around, we begin checking all of our electrical connections, so checking continuity, making sure everything was connected properly and no wires were crossed before we actually power everything up. More second skin wall goes up, so on that day we actually completed wrapping the house in our second skin wall. So this was a big moment for us because we actually only ever had one panel on the house in Australia, so we'd never seen the whole wall attached to the house before. One of the things we had to do, just based on the competition standpoints, was install a full fire sprinkler and detection system, just from a safety standpoint. So we began plumbing that up and attaching our pump to our fire suppression system. And we also installed what's called our mechanical skids. So here on the image, we basically had these 3 units which just pick up and slide nicely into the container, and they contain our hot water unit, our outdoor heat pump, air conditioning unit, and then our PCM tanks. So these PCM tanks, or phase change material tanks, actually acted like a thermal battery for us. So we can use our air conditioning system to charge these tanks, which are filled with water and a phase change material. So essentially we charge them up during the night when our air conditioner runs at a higher efficiency, and then we can use that cool water and discharge it during the hot Dubai days to run our system. So Dubai has a really high peak load during the middle of the day. That's when the most of their energy is used. But we can actually shift our peak load to the middle of the night and then just use a small pump and our thermal battery to run our system during the day. So that actually got us a lot of points in terms of energy efficiency in the house, and was judged really well. So day 8, we're also airtight ceiling. So one thing in the competition we really wanted to show was having an airtight house, gained some really good benefits. So every single join, seal, everything you can think of was taped with this airtight red membrane. The only thing that really hampered or didn't benefit us with this airtight ceiling was that when we were touring 50, 60 people through the house, our air conditioning system can't handle the amount of CO2 that's built up, because it was designed for 8 to 10 people, not 60. So we had some issues during the touring periods of actually CO2 going through the roof, just purely based on how airtight our building was. So day 9, solar decathlon, we finally got up to installing our solar PV system. So in one day we managed to move 2 tonne worth of solar panels up onto the roof and then install them all in one day. So these solar panels are quite unique as well. I'm not sure if you guys are familiar, but they're a company called Tractile Solar. So an Australian company that make basically a building integrated solar tile. But the interesting thing about this is, what got us a lot of points as well, is that actually, one, obviously produces your electricity. So we had 10.4 kilowatts on our roof. Number 2, they actually completely replaced your roof construction. So we didn't have sheet metal or tiles or anything under the solar panels themselves. They were our roof. And then number 3, they can be plumbed together, so they have water channels that run underneath them. So all our domestic hot water was obtained from these solar tiles as well. And you can imagine in the Dubai heat, so we were measuring our solar panels without water, in them reaching 85 to 90 degrees, which was greatly reducing their efficiency. When we were pumping water through them, we could maintain it at about 45 to 50, which was greatly increasing our efficiency, especially in that 35, 40 degree Dubai heat. On day 9, we were connected to the grid, so we got sign off on our AC grid connection. So we were the first team to actually get power into our house, which is a really nice change from carrying around spotlights everywhere that would often go missing and people would steal them. We also began working on our wiring up our electric vehicle charger, and also plumbing and installing actuators between our outdoor heat pump and our phase change material tanks. So as you can see here, our house is slowly taking shape on day 9. Day 10, we plumbed our hot water system. So as I said, we had a building integrated photovoltaic thermal system. So these copper pipes here that they're working on with the oxy-soldering iron were connected to our roof section. So basically the water ran from the tank up to our roof where it was heated and then brought back where it could be used in the house. Day 10, we also started installing sensor cables. So as I mentioned before, basically every aspect of this house is monitored. So things from your temperature, humidity, lighting, energy, basically everything. So to do that, the organisers said you need to run all these sensors throughout your house. It's your job to do it. We don't care how you do it, you just need to get it done. So we had to plan in advance how we're actually going to run these cables in, which can sometimes be difficult. So basically we had to produce drawings and that kind of thing and plan where the cables were going. So they were going to begin here at their monitoring panel and then work their way up and through the house. But lucky for us, our trusty services gap was there that we used to connect all of our air conditioning ducts. So essentially we just ran the cables through there, up onto a cable tray, and then they just dropped into every room where they needed to. So on that day as well, day 10, our energy storage and inverter were wired to our solar PV system that was on the roof. The energy storage units we were using, we actually used two. They're called an E3DC S10 Mini, so it's from a German company. And they're an all-in-one unit, which is really good for us, I guess from a simplifying things standpoint and from a control standpoint as well. So each one contains a 7 kilowatt inverter and 6.9 kilowatt hours of lithium-ion energy storage. So we had 13.8 kilowatt hours of energy storage total, which was just under the 15 kilowatt hour limit that was set by the organisers. Day 11, our energy storage and inverter were signed off to be connected to the grid. So this was another win for us, as we were the first team out of the 15 teams to be connected from the DC side of things as well. So we were the first team to begin producing our own electricity. We're also finalising our EV charging connections as well as our HVAC connections and filling our system with water. So we had some water tanks or bladder tanks that were under the house that we used to basically provide domestic water to the house, as we weren't actually connected to a mains water connection. And we also had to fill up our HVAC system as it was a water-based system as opposed to an air-based system, as I mentioned before. So day 11, we had some visitors from the University of Wollongong in Dubai, so we gave them a short tour of our construction site, and as you can see, we're getting closer and closer with the house reaching its final form. So on day 12, a lot of the commissioning began with some of our students. So basically we started commissioning our IoT, or Internet of Things, building management system, began fitting off switches and power points, as well as testing our automated windows that we had throughout the house. We also began installing lights under our second skin wall that would act as basically an architecture feature that we could change via our BMS to whatever colour we wanted. And we also started installing decks and handrails that were at the front and back of the house. Day 13 come along, so we're getting really close to the, 15-day time limit of the competition. We started commissioning our electronic thermostatic mixing valve taps. So they're basically just smart electronic taps that we helped develop with the company Enware. I'll have a bit more about them later. And began wiring all of our air conditioning controls. So basically, we had quite a complex air conditioning system because we wanted to individually be able to control temperature, humidity, and CO2 separately. So it was quite a custom, integrated system we had. So on that day, we're bringing all the relevant cables in and connecting those to the various controllers and actuators and that sort of thing. Day 13, we were painting as well. Then day 14 rolls around the house, so basically we're doing the final touches on the house, fitting everything off, putting light bulbs in, installing appliances and getting everything cleaned up, ready for day 15. We're also testing some of the air that was coming out of our HVAC system and that sort of thing. But this was a really interesting day because late in the afternoon it began to get, this is one of my favourite photos from the competition, by the way. So that's a couple of guys on top of our house. But late in the afternoon, it began to, the temperature dropped really rapidly and it began to get very, cloudy off in the distance. And then basically before we knew it, site looked like this. So not the blue skies that we were used to, but all of a sudden there was just dust and sand everywhere. And what happened is the storm rolled in. So Dubai usually has about 3 days of rain a year. We copped all 3 of them in the 2 months we were there. So this was the first one. So before we knew it, it was absolutely pouring rain like you've never seen before, which we'd never expected in Dubai. It was actually really, really dangerous. The wind was blowing extremely hard. Things were flying around site, as you can imagine. And a lot of teams actually had some equipment damage just due to debris flying around and hitting things they shouldn't. So basically we had to just shut down site and remain in, they weren't even buildings, they were tents that were beginning to leak and rattle and feel like they were going to blow away. So that was a pretty interesting experience. But anyway, we were able to get back to work that night, and then day 15 rolls around. So we had some more final touch-ups to do on day 15. But then ultimately we received all 30 plus signatures to sign off our building for all the safety standards and that sort of thing. And important to note, again, we're the first team to receive full sign-off. So this is probably my favourite photo from the competition. So as I was saying before, in Australia, we never got to see our house in the full form, like its final, I guess, completed state. So after we received that last signature, we all just came outside and just sat on the ground for a good hour and just enjoyed, you know, what we've been working on for the last 2 years. So this is a real special time for us to just sit back and soak it all in. So I'll just take you through a few photos, both inside and outside the house once it was all completed. So this house will be rebuilt probably in the next few months. So one of these I'll be sure to get an email out to let you all know that you can come and tour it in Wollongong if that's something you're interested in. So this was the front of the house. That's the back of the house. You notice a lot of our windows were actually on the back or the northern side of the house in the northern hemisphere, so we can avoid the direct heat coming into the house while we still have plenty of natural light. So these are the lights that made up our second skin wall. So they're all, the controls we developed for them were all student made at UAW. So essentially we can control those in our in-house app. So you can just open your phone up and change the colour of the deck or the wall or even some of the internal lights to whatever you want. Our theme, we had a bit of a pink theme, as you would have noticed with our construction shirts. This is our front deck. So in the UAE, they have a real, I guess, they really like their privacy, particularly with parts of the house that are facing the front of the street. So we introduced that green wall to increase privacy in that area. This is our back deck, probably one of a lot of people's favourite part of the whole house. So as you can see, we've got the ceiling fan there, and one of the beautiful things was a lot of the time in the afternoon there'd actually be a nice breeze that would come up from that side of the house. So sitting in this shaded back deck area was often, 10 degrees cooler than sitting out in the Dubai heat. So a lot of our team were just hanging out here during the competition. That's the back ramp heading outside of the house. That's our kitchen. So again, we had a coloured splashback that you can make any colour you want to. A lot of the time we'd have it matching the exterior lights on the house. This is the dining room. So as you can see, lots of natural light coming in here with the high celestial windows. So basically we could also, so there were 3 windows that ran up this side here, and then a window that opened here. So we could get a lot of cross ventilation coming through, and we could also exhaust any hot air that was built up in the house just straight out those windows. So again, the dining room. So this is our main bathroom. We made it nice and big from age-related standpoint. We were able to have wheelchair access fully throughout the bathroom. That's our front entrance on the left, and then our small water closet on the right. So we decided to have 2 bathrooms, or a water closet at least. Again, from the standpoint of the Middle East, they like to have kind of more family sections private. So this was more for, I guess, visitors, you could say. This is our main bedroom. The living room that goes all the way through to the dining room. So we really like the idea of an open plan living. But again, from the privacy standpoint, you can actually shut off that full section of the living room. So if you wanted to keep the dining room private, that's possible as well. This was a guest bedroom / study. And then onto some of the technology. So as I said, we had a fully building integrated photovoltaic system. So you can see that implemented here. It looked really, really nice on our house, particularly with the dark grey flashings you can see there. And that was it on our house. So it integrated really well compared to some of the other houses which just had your standard solar panels. As I mentioned before, we had the 2 batteries in the house, as well as a Hager Vega D enclosure which had all of our protection and automation gear. And then we also had a window controller, so all of our windows, bar 1 I think it was, are operable, so we can open and close them with switches. Because one of the things we found our research of particularly people living with age-related disabilities and arthritis, often they find it hard to open windows, which can kind of hinder how they use their house. So we wanted that possibility to be there just to open it via a button. So as I mentioned before, here was our mechanical equipment, but once it was all set in place, we put these shading screens in front of it. One, they look good, and two, it also keeps a lot of that heat from directly hitting that equipment. So this is a really interesting one, which we really love showing off to the public. So basically these two, we can call them artworks, essentially sat either side of our, the entrance to the bathroom in the main dining area, but they weren't actually art, well, they were artworks, but they have a dual purpose. So they operate as radiant panels as well. So basically what we can do is we can, just via a switch or via our building management system app, we can turn these things on, and then cold water begins to run behind the picture itself. So it's essentially small little pipes that run behind the picture, and they basically provide almost instant relief from the heat. So you can turn this on and then go stand next to it, and it radiates its cool heat to you and you radiate your heat to it. So our idea being that from a health standpoint, if you're getting elderly and you maybe get some kind of hot flush, or you just want some immediate relief from the heat as you get home, you can just turn this on and stand next to it, and it's really nice. But it also has the dual purpose of looking quite nice in the building as well. So we had an EV charging station. As I mentioned before, we had to basically drive an electric vehicle, or it was a Chevy Bolt, throughout different parts of Dubai throughout the competition. So we had a 7 kilowatt EV charger. It was a Hager Whitty Park, and we also fully integrated it into our building management system as well, so we could basically vary the charge rate if we wanted to basically have it match our solar generation or something like that. We used the DALI lighting system. So DALI is basically a smart addressable lighting system where you can basically program each individual fixture in the house. But the biggest benefit from our standpoint, both from a modularity standpoint, you only need one lighting circuit in your house connecting all these cables, as opposed to the 10, 20 you might otherwise need. So for us, that really increased the amount of speed that we can make these connections when we were building the house. But also it reduced our lighting cables by a factor of 10. So from a sustainability standpoint, we've got one lighting circuit as opposed to 10 extra PVC cables that we'd be running through the house. And for that, we used the KNX to DALI gateway, again from Hager. As I mentioned, we developed a custom RGB lighting controller for our second skin wall lights, as well as our lighting strips that we use throughout the house. So this was just made with a little low-cost Wi-Fi controller. So off the shelf, you're probably looking at maybe $100 or $200 for something that does a similar thing, and we made them for about $6 or $7 each, I think, for each controller. The smart plumbing fixtures. So this was probably the biggest hit in the whole house, I think. So as I mentioned before, we developed these with Enware. So essentially what it is a regular plumbing fixture, except there's no mechanical valves involved. So basically what it does is the taps themselves are free spinning. So from a health related standpoint, that's really easy because you don't need to mechanically try and turn a tap on if you have something like arthritis. Even easier than that, sometimes you can actually, or you can, just tap the plumbing fixture itself on, so you can just press the tap and it'll turn on. Another benefit too is you can individually control the temperature coming out of each fixture. So we can go into our building management system and say, the kitchen, it's fine for it to come out at 45 degrees, but the shower, we don't want it to come out any hotter than 35 degrees to prevent things like scalding or what have you. Another thing, we linked it to our Amazon Alexa, so we could actually tell the taps to turn on and off. So again, from a health standpoint, if you're caring for someone, you could say, Alexa, turn the shower on, as you're helping someone maybe get out of their wheelchair, and it would turn the shower on for you. And then the other cool thing, which everyone loved, was it actually had visual feedback. So you can see here, as we turn the hot on, it turns more red. As we increase the cool or the cold water coming through, it begins to change temperature and shifts towards the blue. And we also incorporated an automatic shut-off too, so if you do wash your hands and you forget to turn the water off or what have you, these will shut off after a specified time, so we just had it set at 20 seconds. So everyone coming through the house absolutely loved this, and we're always super interested in, that innovation that we incorporated. So that brings us to the actual competition period itself. So we had a few extra days to commission the house. So you can imagine, basically the commissioning that we did here in Australia was during winter in Wollongong, which is a very, very different climate to coming out of summer in Dubai. So we almost had to overhaul everything and just make sure everything was working properly as intended. So that was some very, very late nights getting the house working. So as I mentioned, we had a fully custom, basically integrated building management system that was very low cost as well. So we're monitoring and controlling everything from our plumbing fixtures, our batteries, solar, basically anything you can think of in the house, we were monitoring and controlling. All actions in the house were controlled via, or were able to be controlled in multiple different ways. So we wanted to keep it basically pretty simple and elegant for someone in the house. So if you just wanted to purely use your standard wall switch just to turn stuff on, nothing fancy, you're able to do that. But there are also, for the tech savvy, you can use Alexa or you can use the app or whatever it may be. Another interesting one we had is we had some predictive analytics in the house, so we could actually ask Alexa, if we were to run the dishwasher at this time, would it use all renewable energy, only partial renewable energy, or no renewable energy at all? So that was some feedback that I guess gives the occupants a bit more of an intimate relationship with their energy and can get a bit more involved as opposed to just turning something on whenever they feel like it. So yeah, being the BMS, we had it all integrated so it could talk multiple different protocols from things that could talk to our lighting, our air conditioning, our batteries, everything. It was all in the one system. As I mentioned before, we implemented a control technique called model predictive control. So we were looking at things like, or our system was looking at things like the weather, how much energy expected we will use, and it was making decisions to try and optimise how we use our energy in the house to ensure we maximise the amount of renewables, but also minimise the cost. So there was an energy tariff associated with how much energy we use. So we wanted to make sure we tried to use the least amount of money possible. And basically that whole system was integrated in an IoT software-free platform called Node-RED, and it was just running on a Raspberry Pi, so free software on a $30 computer. So the competition period was 10 days. We toured the public every day. Outside tour periods, we had to maintain strict indoor thermal comfort. We always had to have at least 2 people in the house between 8 a.m. and 8 p.m. We had to operate appliances, drive the EV, turn the lights on in the evening, and also operate a TV and computer. So we just need to make sure the house operates like a house. For the air conditioning system, we had to maintain temperature between 23 and 25 degrees Celsius, so just a 2-degree band. That's probably better than most fridges can do. The relative humidity between 35 and 60%, and CO2 below 800 parts per million. We needed to be net positive energy, and they also wanted to see solar PV that served multiple purposes. We had to wash and dry towels, boil away water, wash dishes in our dishwasher, maintain the oven at 220 degrees for an hour. All these different things to basically make sure the house operated as it should. So the driving tasks were run basically every day, so we just got a certain location we had to drive to in Dubai. But what was also interesting was we actually had to maintain a low energy consumption. So I didn't fully agree with that rule, because what happened is every team was driving along the highway at 30 kilometres an hour for this whole competition, which in Dubai with the Ferraris and Lamborghinis that are driving around at 10 times that speed, I don't think it was very safe, but maybe they'll, review that rule in the future. As I mentioned, we also had to draw hot water into an esky, so draw 50 litres of hot water, boil away water, wash and dry towels, so we had to make sure that the towels weighed equal to or less than at the end of the competition. So this was the monitoring panel, and these were the pedestals that were set around the house, so they monitor temperature, humidity, lighting, all those various factors. And there's one there. And then the monitoring panel, so this measured, or basically we could check up and cross-reference our building management system to what data the organisers were getting. So if there was any discrepancies, we could bring that up with them. So as I mentioned before, we needed to maintain temperature in the house within a really tight band. So a quick overview of this graph. This curve here is our outdoor temperature. So as you can see, it's getting up around 35 degrees. But this line here is how well we're able to maintain the indoor temperature. So we actually did really, really well. So our big kind of complex HVAC system operated really well during that time, and it actually led us to winning the comfort conditions contest. So we were able to achieve nearly 107 points out of 120, which is really, really great for us. On that energy too, so this is a graph of our energy system. So this is the energy we imported from the grid on a typical day. So as you can see, it's quite low. This is our energy consumption. So when I was talking before about the model predicted control, basically what the algorithm wants our energy consumption to do is nearly match our solar production. So you can see here it basically has a similar representation to a solar curve. So that's our solar curve laid over the top. So a lot of our load fits in the middle of that curve. The excess energy from our solar during that time is used to charge our battery, which is then used to discharge in the evening to meet all of our energy requirements. So basically during that time we were almost operating the house like a Formula One car. We were constantly making little changes, trying to maximize the amount of points we can get. You know, if we increase our set point by 0.2 of a degree here, can we save X amount of energy? So it was just an ongoing process that I actually found more exhausting than the construction period, just purely because you're always constantly thinking and using your brain and trying to maximize the amount of points you can get. So this is basically what we were looking at every day. So it was a rundown of how much points you were in comparison with the other teams. So it was pretty anxiety inducing going on this website every morning when you wake up. The coffee machine, so 80-cent coffees became our best friend during this time period. And we're also touring judges through. So this was a difficult one too, because you only got 15 to 20 minutes to tour judges through. So we essentially had to compress 2 years of hard work and dedication and blood, sweat and tears into a 20-minute quick spiel about the house. But it all started paying off. So we had a bit of a rough run early on in the competition, the first few days, but then after that we started to win some trophies and kind of climb our way back up from the middle of the pack towards the leaderboard. Another interesting thing, we actually hosted dinner parties for other teams, so we were able to meet a lot of the other teams, which is one of the best parts as well, kind of meeting these like-minded individuals and talking to them about their experiences. You know, we're all really in this together for the same cause. And we even got some time to show them a bit of AFL footy in the square on one of the last days. So that brings us to the very last day of the competition. So I'm not sure if you can read that, but at that point in time, we were in third place by 0.31 of a point out of 1,000. So it was extremely close. Virginia Tech had pretty much taken a comfortable lead. So the American team, this was their, I think, 7th time doing a solar decathlon, so they had it pretty much on lockdown by that point. But we had one award left, which was the Innovation Award, and it basically could have gone either way. We could have ended up second, or we could have ended up 4th or 5th, so we weren't really sure how it was going to go. So in third place was the team who was just a hair in front of us. So we thought, oh, this could potentially be good, potentially be bad. We were happy for them. They were our next door neighbours and really nice team, so we're happy they got third place. In second place was the Americans, which shocked everyone. So they had a house called Future House, which was, you can almost describe it as a spaceship that didn't leave Earth. Everything was white, slick, crazy innovation. So everyone was positive that they were going to win this competition. So the interesting factor about this competition as well, it was actually a weighted sum from every single judge that had been through your house. So the judges that went through architecture, communication, energy efficiency, they were all different, but each one assigned a certain amount of points to innovation. So this was almost like the all-rounder award. So second place was the Americans. At that point, I was a bit disheartened. I thought we're going to get 4th here, and I thought the Romanian team was going to get first. But sure enough, they were announcing the winner, and the Prince of Dubai was there at that point. So this was the first competition where they actually did everything in Arabic, so we weren't really sure what was going on. So a lot of Arabic was being said, and I was like, come on, come on, come on, come on. And then all of a sudden we just hear the word Wollongong. And then we ended up getting first place in innovation, like right at the end, which leapfrogged us from third place into second. So we were all absolutely ecstatic for that. Yeah, thank you. So lots of hard work and dedication. We were really glad to see it pay off. So quick rundown of the score. We received second place overall, so 905.56 out of 1,000. We got first place in innovation and comfort conditions, second in energy efficiency, and third in sustainability and house functioning. And then we're usually in the top of the pack for the remaining awards. Some other awards too, there was actually a few special awards that didn't account for points, but usually had some extra prizes attached to them. So for interior design, we actually received first place which we're really proud of because we actually didn't have any architects or interior designers in our team, so we're all kind of winging it. Building integrated photovoltaics, we received second place, so again, we're really proud of our solar system that was on our house, fully integrated. And then creative solutions, which also had an extra cash prize attached to it. We had second place for that as well. So there's all our trophies in the house. And that was on the day after. So nice relaxing day where we could just enjoy the house and not have to worry about making it work anymore. So what's next? So the Desert Rose is back at the Innovation Campus in Wollongong. It's currently sadly just sitting in its 8 shipping containers waiting to be rebuilt, but we're almost there with the approvals and that sort of thing to get it up and running. So it should be able to put hammer to nail within the next couple of months. From then on, it will act as a living laboratory for years to come. Lots of research will happen in the house. The cool thing too is you'll also be able to stay in it if you wish. So basically you can come, if you're ever staying in Wollongong, pay a small fee and be able to be one of our little mice that are running around our laboratory. From my standpoint, I'm looking forward to the house to be rebuilt, mostly so I can begin passing on a lot of this knowledge we've learnt to the next generations of decathletes. I really want this to become an ongoing thing for the university and for other universities, so being able to pass that knowledge on to up-and-coming students, I'm really looking forward to. So our plan is to basically build what's called Sustainability Street. So we've already got the Illawarra Flame House built at the Innovation Campus, but we want to get the Desert Rose right next to it and then almost have a lot here that we can develop over time and even invite industry in if they want to have a prototype house or something they can build on site. That's the plan. So from that standpoint too, we also want to basically implement almost like a smart microgrid. So we've already got the Illawarra Flame House and the Sustainable Buildings Research Centre, which all have solar PV, energy storage, thermal storage, those sorts of things. So once the Desert Rose is in, we want to interconnect all these buildings and get them talking to one another and hopefully make one of the most intelligent, sustainable, precincts in the world. So for myself, I'm completing my PhD related to a lot of the control side of things on that smart precinct. So the Desert Rose will act as a test bed for a lot of my research. And from that, I'm hoping to kind of start up a business in the next few years with a lot of those skills I've gotten out of the Solar Decathlon competition. So reflection, the Solar Decathlon was by far the most rewarding experience in my life. I've never learnt so many new skills or put so much time and effort and hours into anything in my life, and hopefully I don't need to put that much time into anything ever again. I was extremely lucky to be part of Team UOW and be surrounded by so many dedicated students who basically took majority of their free time for a good 2 years to basically just build this house and get it over the line. And it's by far the best way, without a doubt, for students to apply what they learn in the classroom and even beyond that, and basically work on something and build something that's really tangible and that they can be proud of. So thank you very much. Any questions? Or